So this will be my first time teaching this to adults. Cyanobacteria basics. Cyanobacteria, most common in alkaline, nutrient-rich waters, but also found in extreme habitats, including hot springs, deserts, and polar regions. Depending on the species, it can form surface, subsurface, or benthic blooms. And Jim mentioned the word benthic. It means the bottom. Prokaryotes, they're simple cells lacking a nucleus and many other cell structures. They're photosynthetic. They make their own food using photosynthesis. They can have specialized structures, including aerotopes, heterocytes, and aconites. We'll talk more about those. Oh, they can be unicellular, colonial, or filamentous. Oh, they reproduce asexually. All right, so here's an example of Crococcus, which if you find this in your microscope slide, it will occur as a single cell. Microcystis is in a colony, though you will see cells broken off. Usually my first indication of what the single cell is if there's a colony next to it. And filamentous, like Dolichospermum. Aerotopes are composed of groups of gas vesicles. They allow cells, colonies, and filaments to change their position in the water column. So like I said, they don't have flagellum. They can't swim around. All they can do if they have aerotopes is rise and sink, and they don't all have them. Heterocysts are distinct cells. They allow atmospheric nitrogen fixation. So you may have heard that cyanobacteria don't need nitrogen in the water because they can fix it from the air. Some of them can, but that doesn't mean they don't need nitrogen. So fixing the nitrogen from the air takes a lot of energy. They would rather get it from the water column. A high nitrogen in your lake will produce bigger blooms and more toxic blooms. And not all cyanobacteria species have them. Aconites are specialized cells that may act as resting stages. Think spores. So it's not a spore, but it acts like a spore. So this can become a new cyano. They're recognized by their larger size, thick cell walls, and granular appearance. And they will germinate when exposed to favorable conditions. Not all cyanobacteria have them. So our cyano ID method, we look at our sample and we say, do we have a colony? Do we have single cells? Is it filamentous? Then we look at the shape of the colony, the shape of the filament, the shape of the cell. Then we want to know, do they have aerotopes, heterocysts, or aconites? And sometimes getting down to the wire, where are they? Are they next to each other? Are they separate? Oh, good. So this is going to be kind of fun. These are 3 important genus of cyanos. 3 words. You're going to leave today knowing these 3 words. Dolly, after me.
Dolly.
Fanny.
Fanny.
Mike. Oop. Dolly is short for Dolichospermum. Everybody? Dolichospermum.
Dolichospermum.
It's easier to remember if you actually say them. Fanny is short for Aphanizomenon. Aphanizomenon. And Mike is for Microcystis. Microcystis. What do we got here? So what is Dolly short for? Don't look at your notes. Don't look at your notes. Anybody?
Dolicospermum.
Yeah. Dolicospermum. What is Fanny short for? Yeah.
Something.
Yeah. A phenomenon. Say it. It's fun. Love that word. Oh, I shouldn't have said that. What's Mike for? All right, we'll let that one out of the bag. Microcystis. Dolly, I want you to think of a doll wearing a string of pearls. Here she is. So, what do I got here? Dolicospermum. So, Dolicospermum is filamentous, and it's going to resemble a string of pearls. Oh, okay, dolly. What are we going to think of when we hear the word dolly? Doll with a string of pearls. What is dolly short for? See, you got it. You got it. Oh, Dolicospermum. Fanny. Ha. Yeah, I wonder what we're doing here. So, Fanny is looks like grass clippings. You see, I kind of took the grass clippings and I made a little fan. So you can think grass clippings in a fan. We'll go with it, right? Oh, back up. What's Fanny for? Yes. Done. All right. What do we think of when we hear Fanny? Grass clippings. And a fan. And what is Fanny short for? Isn't this fun? All right, Mike. Oh, so when you hear Mike, I want you to think of cotton balls. And Mike is short for? Microcystis. So yes, it is a colony. Mike, what do we think about?
Cotton balls.
Cotton balls. Mike is short for? See, you know it. All right, what do I got here? I don't know. Let's see. Oh. What do you think we have here? Oh, you guys are so good. Is it a string of pearls? All right, you know it. It's cotton balls, right? Green cotton balls. Microcystis. Mike? Microcystis. All right, you guys are sharper than those high school kids. What can I say? All right, what do we have here? You go, you go. Yes, what does it look like? Cut grass. So a phenomenon, they're actually filamentous, but they like cling together in these sheaths called,
Like bamboo.
not popsicles, fascicles. Fascicles, yeah. And under the scope, you will occasionally see the single ones. And in the first thing, though, have you got them in the fascicle? Then yeah, that's probably what it is. And you take another look at it. Cut grass, Fanny, phenomenon. All right, what do we got here? What do you think? String of pearls. And string of pearls is? Dolly, Dolicospermum. Yeah. All right, so.
A quick question for you, Gloria.
Yes.
In your,
I may not have an answer.
it's okay, in your picture on the, I can pronounce it right, the phenomenon,
Yeah.
you had a spiral, just like the Dolicospermum.
Yeah, well,
Was-
as I mentioned, my lake tends to be a fruit salad.
So is that the relative scale, where they like zoomed in?
Yeah,
on
that would be
same
the
amount?
same scale,
So
yeah.
is that much bigger?
Yeah,
The phenomenon, is that much bigger?
Versus the
than
Dolicospermum, yeah. So here's some Dolicospermum. Dolicospermum is the genus. Now here's some species. Dolicospermum flossaqua, Lemerani, circulani, and crassum. We get, this is my picture, this is mine. We also get crassum. It's very regular. It looks like a slinky. It's unmistakable. And here's some straight forms of Dolichospermum. But we're not doing this under the scopes. Other common cyanos, Crococcus, this is the one that occurs in single cells. Warocinia, this is from Long Lake. It's fun. So it'll have that colony, and then it'll have the single cells around it, and it kind of has a see the dark ring around it. You're not going to see that in the microcystis. And here's Cylindrospermum. So the note says the aconite is adjacent to the heterocyte. Heterocyte aconite. And, any guesses? All right, here's my fruit salad.
I was gonna say.
Yeah, do I have a pointer? I have a pencil. All right, what do we think this is? Dolly? Dolichospermum, yes. What do we think the grass clippings is? Phanizomenon. And what do we think this is? We're not zoomed in real good, but I'm going to say that's microcystis. And you will have this in your notes. So when you go home and you buy a microscope and you start taking samples from your lake regularly, you're going to be like, well, I got Dolly, Fanny, and Mike. But there's a lot more. And here's places where you can find them. And as I said, I'm training artificial intelligence to identify cyanobacteria in the Great Lakes region this summer. And if you want to send me a sample, I just need the tiniest bit. But you want to ship it overnight with a little ice pack in there, and I can tell you everything you've got. And you'll be helping me, because I have to get 100 samples before October. And, microscope basics. So getting down to the microscopes. I borrowed this from a high school biology teacher. Here's your microscope. Ocular lens. Nose piece. Objectives, arm, story. I've got the lights on. You don't have to worry about that. Microscope care. All right, we're not carrying our microscopes around. You're going to always start with your lowest power. These are both set on the lowest power. After you zoom in on your sample, you can go up to the next highest power, but that's probably as far as you need to go. All right, comparing the powers of magnification. We can see better details with higher powers, but we can't see as much of the image. First we're going to see, are they filaments? Are they colonies? And then we zoom in and get them a little closer. Turn on the microscope. We're on. Low power. We've got that on. The slides. So you are going to get one of these lovely little glass slides. After you've got full PPE, we're going to put masks and gloves on. You're going to use a pipette, and you're going to take a sample out of our jar. Remember the jar test. Where's the cyanobacteria? At the top. So you're going to want to take a little drop at the top. After you've got your drop on your slide, you're going to take a slide cover and just kind of let it fall on it. And then this is going to go under the scope. All right. It's fun. It's all fun. So note how they're lowering the cover slip slowly. And you want a healthy drop. If you've got too tiny of a drop, you're going to really smash it with that cover strip, and it will distort your sample. I think we're on it. So full PPE. Everybody needs gloves and masks, including me. I have 2 scopes, so we can put, you want to do it one at a time or do it in partners?
2 at a time.
2 at a time? Okay. Let me get my gloves. Here's a fun poster. These are things you are likely to find under the slide. If you find something in your sample, don't shout it out. Let other people have the experience of discovering. And here we go.
You want the
And,
one of those, a slide?
Here we go.
I sweated.
Going to use a pipette.
All right.
All right. You're going to take a drop from the top of the sample where the cyanos reside.
Is it okay that some of it gets on the?
All right, take a look.
Okay, so let's see. Okay.
Shout out what you see. Look at this chart. I just wanted briefly to talk about the toxins. So, did somebody find Dolly? No, okay. So here's a phanoxaminon. Does it produce microcystins? Yes, so that's what we tested for. And as you notice, it also can produce, we did not test for it, but it can produce neurotoxins as well. And then down here, we've got microcystis, which produces microcystins and also nodularins. So that's it. That's all I've got. So, all right.